Hi everybody. I recently posted a video of my new fiddle yard onto YouTube, and several people have asked me to do a video explaining how it works. It basically has 5 tracks on a traverser with a single large Pico Y point at each end. There's also a siding at each end, giving a total of 7 storage tracks using just 2 points and the traverser. Because the fiddle yard is highly visible on the layout, I've included a background, scenery and cosmetics, but the cosmetics are not quite finished yet. Difficult to know how to pitch this, so for those experts watching I apologise for being too basic, and for those beginners I'm sorry that it isn't detailed enough. Still, if you have questions, put them in the comments please, and I will try to answer them. The dedicated control panel is mounted above the yard. The traverser is controlled by a double pole switch that just reverses the polarity of the DC motor that drives the traverser. At the right hand end of the fiddle yard, the connection to the main loop can go either way via a triangle of points. If the triangle of points is set to go left, clockwise onto the main loop, then the wiring will be the same as the other end of the fiddle yard. But if the triangle is set to go right and anti-clockwise onto the loop, then the bus wires will be reversed. More on that later. The points are driven by a DCC Concepts IP digital motors controlled using an alpha switch D board like this. In this case, the alpha switch board drives the points directly through the terminals of the Cobatl digital motors. The fiddle yard is constructed on 2 long 2x1 pieces of wood that run the length of the yard and the approaches. They're mounted about 10 inches apart. On top of these 2 bearers is mounted 9mm plywood strips that raise the main baseboard for the approaches by 9mm. The baseboard on the approaches is also 9mm ply. The traverser is mounted on 2 standard drawer runners that happen to be 10mm thick, so the runners are recessed into the bearers by 1mm to make the top surface of the approach baseboard and the traverser baseboard at exactly the same level. It's only looking at this that I realise that this runner is not completely level, but that's not important if the 2 baseboard tops are at the same level. On the left is a stop block that is screwed onto the traverser baseboard in exactly the right place to stop the traverser with the tracks aligned. There's one of these blocks at each corner of the traverser. I have a small Select Mini 3D printer and use that to create a gear and rack to drive the traverser. The rack is attached to the bearers and the gear to the traverser. The next stage was to create a motor mount with the printer. There's a whole range of geared motors available on Amazon as 12-volt reversible worm gear motors. They come in a wide range of speeds. I had a 6 RPM motor and used that, which gives a very good speed. This is the motor and the rack before it was fitted. You can see the rack alongside the motor, and the motor is mounted underneath. This is the motor actually mounted under the baseboard of the traverser. You can just see the end of the rack that sticks out on the left-hand end of the motor. While the traverser has physical stops at each end of its travel, it's also necessary to stop the motor at the correct point. For this I built a small holder for a microswitch with an adjustable M3 screw that can be set very accurately and locked in place. As the inertia of the motor carries on for a fraction after the current is switched off, the microswitch triggers just before the traverser hits the physical stops. This is the microswitch mounted under the traverser baseboard. You can see the M3 adjustment screw. The tracks were laid across the join between the approach and the traverser. One sleeper was cut out each side of the join and replaced with fibreglass sleepers from DCC Concepts. They have isolated metal patches to which you can solder the rail. 4mm brass strip was glued under the sleepers to ensure that their height matched perfectly, and a 2mm hole drilled through the centre of the sleeper, which was glued and screwed down to ensure that they didn't move. Only then was the rail cut across the join. This is the packet of sleepers from DCC Concepts. Back to the control board and the problem that the DCC bus can be red-blue at one end and blue-red at the other. The solution to this was to wire a 4-pole 2-terminal relay to switch the polarity of the centre 3 tracks depending upon which end they were connected. The board for this has the two-way switch as its input top left. The DCC bus from each end feeds in top right. The 2 stop microswitches are wired in bottom left along with the output to the motor. The relay sits in the middle and the appropriate DCC bus connection comes out bottom right. That's about it. The way to control the triangle of points with just 3 buttons on the control panel is quite complex, and there's a whole thread on it on the DCC Concepts forum, which you can find on dccconceptsforum.com. It's a great resource for modelling information. DCC Concepts is a fantastic resource for all technical modelling stuff. I've bought a lot of stuff from them and received excellent support and service. I've no direct connection or affiliation with them. I think I wish I had. Interestingly enough, they're currently recruiting, so if you fancy turning your hobby into a career, give DCC Concepts a call. If you have any questions, please put them in the comments below. Thank you. In the meantime, keep safe.